Hello everyone. In this video, we're going to talk about crystallization, a water of crystallization. Before we go and understand what is water of crystallization, as you can see here on the screen, there are three different substances and they have three distinct colors. The first one is cobalt nitrate, which is a more like a red blood color. The next is a nickel sulphate, which is a more of a bluish color, and the iron sulphate is bluish green color. It's a more of a greenish blue color, right? Now, these are compounds which get these distinct colors when they have water present in them. So what does this water do? Even if it is a dry compound, cobalt nitrate or nickel sulphate or iron sulphate, they form this. If you can see the picture, they have these tiny grainy like structure. That grainy like structure is formed only when water molecules are present along with them. Now we need to understand that here the water is not present, or that the water which is present is not going to react with that chemical. It is going to be present in them to give them that distinct color and the distinct strong structure of the crystal, the three-dimensional structure of the crystal. To understand what is crystallization, I'll show you a short video where you see how copper sulfate crystallizes. Okay, more precisely copper sulfate solution crystallization. So let's look into the video. Then we'll do look into another video and then I'll come back to the explanation. Okay, so let's look into the video. So as you can see here in this particular glass, they have put the person is going to pour copper sulfate solution. Before even I run the video, just look at it, the arrangement. He has placed a pencil which has a thread tied, and the thread is immersed inside the glass, and he is pouring the copper sulfate solution, right? So what happens when the person completely fills it with water, as with the copper sulfate solution, and leaves it? So what happens? We'll watch it. Okay, we'll watch what happens. So in this case, he has completely filled the glass. The thread is inside the glass, immersed completely into the copper sulfate solution. So watch what happens after a few seconds or after a few hours. So as you can see here, when he lifts up the pencil along with the thread is being completely covered by copper crystals. These crystals are tiny sugar-like crystals. Sugar crystals or tiny three-dimensional solid shapes which are being attached to the thread. This is called as crystallization, right? And if you watch the watercolor, it's a little bit more lightish blue compared to the previous one, right? So this is one of the way of crystallization. Water of crystallization, salt forming crystals, sugar forming crystal, or any liquid forming crystal is nothing but it's a solidification process of the particular compound from its liquid state to solid state. It's a physical transformation where the liquid transforms into a solid, and while transforming into solid it forms these three-dimensional structures which are called as crystals. Now, in this particular section of the experiment, the video is going to show you the experiment where the copper sulfate, which is bluish, what we say, ocean blue color crystal, when it is burned, what happens to the crystal, and the color of the crystal, especially the color of the crystal will change. And then when they add water to it again, and what happens? So just watch what happens with the experiment. So the materials required are hydrated copper sulfate. Hydrated means water molecules are present. Then distilled water, a test tube, the spatula, burner, and the holder. So what first thing is procedure, right? So what they're doing, they're taking the copper sulfate using a spatula, and they're taking it into the test tube, like one spatula full of copper sulfate. With the help of the holder, you're holding the test tube under the above the burner. So they are heating it. So just observe gradually what happens with the copper sulfate. The bluish copper sulfate, which was oceanic blue in color, that will gradually change into white. Why? I'll explain it. So can you see it has changed into white? So when you're heating copper sulfate, what is happening? The water droplets which were binded or bounded or combined physically, which were sticking to the copper sulfate powder, right? Which was sticking to the copper sulfate powder to give them that distinct crystal structure and the color, they will be first evaporated because they'll convert into vapors and they'll be moving out of the test tube, right? So once the water droplets are being evaporated out, the left out is nothing but copper sulfate, which is whitish in color. Clear? So now they are going to add water droplets into this hydrous copper sulfate. What are they doing? They are going to add water into the anhydrous copper sulfate. Anhydrous copper sulfate is the white powder. Anhydrous means no water present in it. So now they are going to add the distilled water in the copper sulfate, anhydrous copper sulfate. So this is the whitish powder which is called as the anhydrous copper sulfate. And once they mix water, see the change in the color. So now can you see the light bluish color coming back and the crystals are a little bit more grainy, means the powder changed. So what did we see? This is what we saw. Initially the copper was a grainy bluish crystal. So if it is a clear crystal, it will be more like a solid crystal, which we saw from the first video. When you powder it, it's more like a grainy crystal, which is copper bluish color. Okay. Now this white color powder is nothing but anhydrous copper sulfate where no water is present. So through the test tube, they are adding a little bit of, through the funnel, they are adding a little bit of water and the color can be seen as changing into again sky bluish color, right? Or oceanic blue. Same experiment they are doing here. In the test tube, they are taking the copper crystal and they are burning it, which we saw in the video. Once you start burning it, the water droplets evaporate out and the color changes to white and it's more becoming powderish, right? So copper sulfate crystal, which seems dry, actually contain water of crystallization. Water of crystallization is fixed number of water molecule. There is a number which is fixed. With one molecule of copper sulfate, 5 molecules of water will be combined. So one molecule of copper sulfate will have 5 molecules of water. And this 5 molecule of water is called as water of crystallization, where the water is binding physically, not chemically. Similarly, when we see sodium carbonate, it has 10 molecules of water molecules binded with it. Clear? And this is called as water of crystallization. Similarly, there will be some molecules of water which will be binded with cobalt nitrate. So that is giving their red blood color to the crystal. Same when nickel sulfate will be binded with some molecules of water, few molecules of water. I'm not clear with it, but it is binded. Clear? Now, gypsum. What is gypsum? Gypsum is actually a soft sulfate mineral which we get from the mineral rocks. Okay, but if you go into the chemical composition of gypsum, it's calcium sulfate dihydrate, means it has 2 molecules of water of crystallization. 2 molecules of water are binded with its crystal. That is when it gives this defined structure. Okay, can you see the 3-dimensional structure? A little bit more, it's not too hard like a rock, but it is like a minerals rock. Okay. Now, when gypsum is heated at 373 degree Kelvin, okay, it will start losing water molecule and it becomes calcium sulfate hemihydrate. So it's going to lose 1.5 molecule of water. There were 2 molecules, and in this one, while heating, 1.5 molecules will get evaporated. How? I'll explain a little bit later. So only half a molecule of water is combined physically with calcium sulfate. So when calcium sulfate is combined with only half a molecule, therefore it is called as calcium sulfate hemihydrate. And the other name, or the common name for calcium sulfate hemihydrate, is plaster of Paris. And plaster of Paris looks like this whitish powder. Okay, when you mix water to the plaster of Paris, again it will become hard and it will form gypsum. Heating gypsum gives us plaster of Paris. Mixing water to plaster of Paris gives back gypsum. Okay, now calcium sulfate with half a molecule, how is it possible? So the actual possibility is that the two molecules of calcium here, this can you see here? These two molecules of calcium sulfate are connected to only one molecule of water. Two molecules are sharing one molecule of water, right? When two molecules are sharing two molecules of water, then right, so from them, if you that is calcium sulfate with two water molecules, so that is gypsum. So this is gypsum and this is plaster of Paris. Same way, if you look into this picture, it's a more complicated picture. Calcium sulfate is going to share half the molecule of water. Here half the molecule is this is a water molecule which is shared by two molecules of calcium sulfate. Okay, so two molecules of calcium sulfate are sharing one molecule, that is plaster of Paris. Therefore, it is hemihydrate, right? When two calcium sulfate molecules get two water molecules together, then it is what? Gypsum. So this is the structure of gypsum and this is the structure of plaster of Paris. Clear? So when we are heating gypsum, what happens? One molecule of water will be removed. Okay, so two molecules have to share only one water molecule among themselves. So that becomes hemihydrate. Yeah. Next is uses of plaster of Paris. Plaster of Paris is used for specially for supporting the bone. That is, whenever any person is broken their bone, and we call it as fractured. So what they do, they actually put gypsum plaster of Paris powder in water. They make a paste and they start applying it around the bone because it becomes hardened. Really, it hardens up after drying gypsum. So it is applied and left so that it can support the bone and it can be treated very well. Gypsum, same way, plaster of Paris is used for making toys or artifacts, decoration materials. Even these idols are made up of plaster of Paris and gypsum, plaster of Paris mixed with water. And the false ceiling are also made up of plaster of Paris. So what did we understood in this video? We understood that gypsum is a mineral which has two molecules of water of crystallization. On heating, it loses 1.5 molecules. Meaning indirectly, one molecule is lost and two molecules will share one molecule of water. That gives rise to plaster of Paris. So we understood water of crystallization. Some substances will form crystals just when they are mixed with a small amount of water molecules, not even tiny or small, a fixed amount of water molecules, and it is a physical binding, not chemical. So once they are physically bounded with these water molecules, they get a definite 3D structure and they have a definite color. Hope this is clear. Thank you.